Hi, my name is Craig Lurie, and I'm the CTO and co-founder of Keeper. This is our on-demand product tour. This video lasts about 30 minutes, and we think you'll learn a lot, so let's dive in. It's estimated that cyber criminals cost businesses $1 trillion in 2020. That's a huge number that may seem too abstract to matter to your business, but think about it. What would a data breach cost your business? Could you recover from it? A big reason so much is lost in data breaches is because they go undetected for so long. If you don't have the tools to mitigate and prevent the initial breach, the damage can be catastrophic. Employee passwords and privileged account passwords are a critical point of entry. Most employees have to keep up with 50 or more passwords just to do their job. Of course, they're going to pick things that are easy to remember, but that also makes them easy to crack. Once in, a cyber thief can do massive damage in very short time, all without you knowing until it's too late. As we read in the news, it only takes one weak password on just one device to cause irreparable harm to a business. Weak password security is the Trojan horse for cyber criminals. Over 80% of all cyber breaches are due to weak password security. Because of this, any cybersecurity strategy and budget must start with password security. Securing your organization's passwords for all employees on every single device they use is essential. Employee and IT passwords are your biggest point of vulnerability. You need to know if password policies are being followed. Are they strong or weak, or have they been sold on the dark web? Are they being reused? You need to know what users and what systems are at risk of account takeover. This is where Keeper comes in. Our solution is chosen by enterprise customers over the competition for three main reasons. 1. Security. We're the most secure product with zero knowledge, zero trust architecture. 2. Ease of use. With over 15 million users worldwide, we have a solution which is loved by users and can be easily deployed. 3. Ease of deployment. We have the strongest solution and the experience to implement in any environment with a high adoption among employees. This is what life looks like without Keeper. Unknown password strength and reuse, no audit capability or visibility into password use, excessive password reset help desk costs, weak SSO security, and password-fatigued employees. With Keeper, you get best-in-class security, flexibility, ease of use, and a world-class support organization. This demo will show you how to prevent data breaches through our enterprise zero-knowledge, zero-trust password management and privileged account management cybersecurity platform. Let's first talk about security. Keeper is a zero-knowledge platform, which means that encryption and decryption takes place locally on the user's device. Keeper cannot access customer data, and users are in complete control of their encryption keys. Keeper implements a multi-layered encryption system based on client-side generated keys. Record-level keys and folder-level keys encrypt each stored vault record and folder. For example, if you have 10,000 records in your vault, you also have 10,000 AES-256 record keys protecting the data. Keys are generated locally on the device to preserve zero knowledge and to support advanced features such as record and folder sharing. Record and folder keys are wrapped by other keys such as the data key and the client key. For users who log in with a master password key is derived and used to unwrap the data key, which is then used to unwrap the record keys and folder keys. Record keys are then used to decrypt the stored record information in the vault. For enterprise users who log in to Keeper with SSO, an elliptic curve key pair is generated locally to encrypt and decrypt the user's data key, which then unwraps the record and folder keys. You can read more about our encryption model at the link below. Just go to docs.keeper.io. Keeper security employees have no ability to decrypt customer data because the keys are managed by the customer. In addition to zero-knowledge architecture, Keeper provides a number of two-factor authentication methods, including Google Authenticator, Microsoft Authenticator, FIDO U2F security keys, SMS, Duo, and RSA. Keeper security is SOC 2 and ISO 27001 certified, GDPR compliant, FIPS 140. We're continuously monitored and tested by third-party penetration testers, and we actively maintain a public bug bounty program with BugCrowd. For more information about our security, please visit our public security disclosure page at keepersecurity.com/security. Keeper is a fully SaaS-based cloud solution hosted with Amazon AWS with dedicated and isolated data centers throughout the world. When enterprise customers sign up, you can select the region where you'd like your data to be hosted. All data stored and at rest in the cloud remains in that region with full redundancy and encryption. Keeper has a few core components of the platform: the admin console, web vault, browser extensions, desktop app, and mobile apps. We'll start off with the end user vault to first review how your users will experience the product. Then we'll review how you deploy and manage Keeper users in your environment. To log in with your SSO provider, simply type in your email address and click Next. After successfully authenticating into the SSO, in this case, I'm using Microsoft Azure, a signed attestation is verified by Keeper, then the user is able to decrypt their vault using their elliptic curve private key. As you can see, signing into the vault is very simple and requires no additional password entry. Keeper's unique and patented integration with SSO providers works with all SAML 2.0 identity products and offers simplicity while retaining full zero-knowledge encryption. Keeper's architecture requires device approval before a user can even attempt to log in and decrypt their vault. When you try to log in on a new device, a device that has never been used with Keeper, you can approve the device one of two ways, either using Keeper Push or requesting admin approval. Keeper Push is a simple and secure way to approve access from any mobile device or desktop computer. We also provide enterprise customers with automated approval methods which streamline the process. You can also log into Keeper using the icon from your SSO dashboard. For example, in Okta, I simply click the Keeper icon. For users who log in with a master password, it must adhere to the policies of password strength set by the admin. If the user has two-factor authentication enforced, you must first pass the 2FA step. In my case, I'm using a YubiKey device for 2FA. After successful 2FA, you can type in the master password. The master password is used to derive a key, which then decrypts the vault. When signing into Keeper for the first time, users can automatically import existing passwords that are stored in their web browsers, including Chrome, Firefox, Safari, iCloud Keychain, Internet Explorer, and Edge. Keeper can also import from CSV files, spreadsheets, or other password managers like KeePass, LastPass, and many more. More advanced users can import data in structured JSON format or develop a custom integration with Keeper's Commander SDK toolkit. Here in the Vault, users can store and protect passwords, documents, 2FA codes, media files, and privileged account secrets such as SSH keys or API keys. Custom fields with a variety of field types can be added to records. And custom record templates can be created by the admin that are tailored to your business. Our password generator ensures that users generate strong and unique passwords for every site. The password generator can be enforced with different domain complexity rules based on role policies set by the Keeper administrator. Records can be created with custom fields and placed into private folders, subfolders, and shared folders through drag and drop. Users can also attach any type of file, such as a passport photo, media file, SSH key, or other secure document type. Drag and drop makes it really simple to quickly protect files in the record. Keeper also supports storage and protection of 2FA codes. The Keeper desktop and mobile apps can scan the QR code from any site that offers two-factor authentication and store the codes in your vault. 2FA codes can be auto-filled into any site when you log in. And they can even be shared among team members. Keeper can be deployed to users in many different ways. We have fully native desktop applications for Windows, Mac, and Linux. We also have a web vault and a KeeperFill browser extension. Keeper is fully integrated into all web browsers, including Chrome, Firefox, Edge Chromium, Safari, Opera, and even IE11. Native mobile apps on iOS and Android provide a full range of capabilities. Keeper desktop software can be deployed to users through SCCM, MDM, public app stores, or direct installs from our website. Based on your security policies, you can deploy any component of the platform. Keeper natively supports Windows Hello, Touch ID, Face ID, and Android biometrics. Offline access can also be achieved with a biometric for both master password and SSO-enabled users when this feature is activated. Encrypted ciphertext is stored locally on each device, and it's also synchronized through Keeper's Cloud Security Vault. If permitted by the Keeper administrator, users can log in and decrypt their vault when they're offline, even on web browsers and SSO-enabled accounts. Offline mode allows users to have access to their vault when they're not able to connect to Keeper or to their SSO identity provider. This capability is available on Keeper's mobile app, desktop application, and extended to business users on all web browsers. On the Web Vault and desktop app, users will know if their vault is available offline via the lightning bolt icon, indicating that their data has been loaded on that device. To log in offline, click the Work Offline button. Note that the use of offline vault can be controlled at the enterprise level through Keeper's role-based enforcement policies. Keeper's autofill technology, called KeeperFill, makes it easy to log in, save passwords, and change passwords on any website or application. Keeper lock icons appear in the login form fields and help the user log in with one click. Keeper seamlessly handles multiple accounts per site. To launch into a website, you can use the Launch button, or simply navigate to the website. Keeper automatically fills the login, password, and 2FA code on the target website. For security reasons, Keeper will never autofill and log into a website without the user's permission. There are many options to configure within the browser extension. The settings screen of KeeperFill here on the browser toolbar gives the user complete control over the workflow. This controls how Keeper prompts for login, filling, auto-submit, saving, and changing passwords. For example, if the user manually types in a password for a website, they will be asked to save the password directly into their vault. Keeper can also change passwords for you. Let's look at a site with a weak password and change it. This password change is synchronized to all my devices in real time, and if it's shared to another user, it will also be updated inside their vault. KeeperFill for Apps is a great tool built into the Keeper desktop application for Mac and PC that lives in the system tray or menu bar of your computer and gives you quick and easy access to your vault using a simple hotkey. You can search for records and access any information in your vault with a few clicks, and then use hotkeys to fill the login and password into applications. KeeperFill for Apps can fill passwords into any native application, such as accounting software, remote connection tools, and even command line tools. For companies that don't permit the use of browser extensions, KeeperFill for Apps provides autofill capabilities without having to install any browser components. Here is an example. You can see I'm using KeeperFill for Apps to autofill a password through a remote desktop connection into a remote Chrome browser, just by hitting one hotkey. There are many use cases for shared passwords. For example, within an IT team, there are privileged account credentials, or within a marketing team, there are shared social media passwords. Keeper provides simple and secure tools for sharing individual passwords or an entire folder. Passwords can be shared with other individual users or within a team. Teams can come from the admin console either created manually, or they can come directly and synced from another directory, such as AD. The user can assign read-only, edit, and sharing permission. Here's an example of sharing privileged accounts among a team of engineers. I'll create a new shared folder called Database Passwords, add a MySQL database password, then share it to the Linux admin team. The default folder permissions screen applies to new records or users who are added to the shared folder at a later time. By default, read-only permissions are applied. It's important to note that all of these sharing features can be restricted to certain roles within the organization, or sharing can be disabled completely. This is a policy that the Keeper administrator can enforce through the Keeper admin console. The Keeper platform provides users with version history of every change made to every record in the vault. To access version history or to restore a previous version of a record, click on Options, and then Record History. To view and restore deleted records, visit the Deleted Items screen. Every Keeper business user receives a free Family Plan consumer license. This license remains active for the duration of the user's employment. When they leave the company, they can carry their personal vault with them and not risk losing any personal information. Any passwords stored in the personal vault will not be affected by the policies in the enterprise. If an employee leaves the company, they'll be able to easily transition their personal vaults to a consumer license. The Keeper Vault login screen has the capability of switching between business and personal vaults with just one tap. When biometric authentication is turned on, switching between vaults is super fast. On Windows, we support Windows Hello, and on Mac we support Touch ID for fast login. We offer several secure add-on products that integrate with the Keeper Vault. Secure file storage protects and organizes confidential files, photos, and IT assets such as SSH keys, digital certificates, passport photos, medical cards, tax and loan documents, or any type of sensitive file that needs to be encrypted. Files are encrypted locally on the device during the upload process, and the user holds the encryption key for complete privacy and security. Users also have the ability to securely share files with other Keeper users and teams, making secure file storage the best way to save and transfer the most sensitive information. On iOS and Android, you can load content from the local device or the camera. Photos taken within the mobile app do not reside on the camera roll of the device. They are encrypted directly into the vault. KeeperChat is a secure messaging solution. With KeeperChat, users can send and receive secure encrypted messages with other Keeper users in the organization. Messages, media files, and documents shared in KeeperChat are fully protected within the vault, and they can be set to self-destruct. KeeperChat supports team messaging, and it's integrated into the team management from the Keeper admin console. All of the information shared within KeeperChat adheres to Keeper's zero-knowledge principles with client-side encryption and user-friendly features. KeeperChat is available on Windows, Mac OS, iOS, and Android devices, and it uses the same login as your Keeper account. BreachWatch scans passwords in the employee's vault against public data breaches in the dark web. We use a secure zero-knowledge method of scanning passwords that alerts users in the vault if a password has appeared in a data breach. Users can take immediate action on these alerts by rotating the password on the target site. Admins can also be notified for privileged account password breaches within the Keeper admin console. Take, for example, this site here has what appears to be a strong password showing in green, but it turns out this password must have been leaked in a dark web data breach. Keeper notifies the user directly in the vault that this password has been found on the dark web and could be used in a stuffing attack or account takeover on this particular site. The critical thing about how we developed BreachWatch is our encryption model. We do not transmit any data to third-party providers. Our infrastructure is built completely into our platform, and we have public documentation explaining the security model. On the BreachWatch servers, a physical hardware security module, or HSM, is used to process, hash, and store billions of unique passwords from dark web data breaches. Each of these billions of passwords is processed on Keeper servers using HMAC 512 hashing method, hashed with a hardware security module using a non-exportable key. On the Keeper end-user client device, when BreachWatch is activated, an HMAC 512 hash is generated based on each stored password and sent to the server using an anonymizer that isn't linked to the user. On the server, a second hash is created using HMAC 512 via the hardware security module using a non-exportable key. Hashes are compared to determine if a password has been breached. Within the admin console, I'll show you how BreachWatch events can be monitored by the admin. The Keeper admin console is where your administrators will provision users, set role enforcement policies, manage teams, and audit the password and privileged account-related security events of the organization. Here in the console on the left side are what we call nodes. A node can represent a different division, location, or business unit within the organization. Nodes can be nested, and each node can have different users, roles, teams, and administrators. Also, each node can provision users in different ways. For example, one node can be used to provision users through Azure, but another node can be used for users that log in with a master password. Smaller organizations may not need to use separate nodes, and so users can be simply added through the user interface or imported through a CSV by clicking Add Users. For users who will sign into their vault using a master password, the user will receive an email invite and they can click through and complete the setup of their vault. The invitation format and content can be totally customized in the admin console's configuration screen. Once the user creates their master password, they begin the onboarding process, which involves importing their existing passwords and a walkthrough of how to create new records. The Keeper admin console provides several methods of automatically provisioning vaults and authenticating users with existing identity providers. Let's review the different provisioning methods available. Keeper SSO Connect Cloud is a SAML 2.0 service that seamlessly and quickly integrates with your existing SSO solution, enhancing and extending it with zero-knowledge password management and encryption. Keeper supports all popular SSO IDP platforms such as Okta, Azure, Google, JumpCloud, Centrify, OneLogin, Ping Identity, and many more. Keeper SSO Connect gives customers the ability to authenticate and provision users into their Keeper Vault on any device and any web browser without the user having to type in a master password. This is critical for organizations that require all enterprise applications to be integrated with an existing identity provider. Setup only takes a few minutes. SSO Connect Cloud supports just-in-time provisioning, which will provision a vault for the user the first time they access the product. The security model of Keeper SSO Connect protects the user's vault with zero-knowledge elliptic curve encryption. As I showed earlier in the demo, users who sign in with SSO simply enter their email on the Vault login screen and click Next. The user is routed through their identity provider to authenticate, and then their vault is decrypted after a successful login. Keeper also provides a self-hosted version of our SSO integration called Keeper SSO Connect On-Prem. Keeper SSO Connect On-Prem is a software application that is installed on the customer's on-premise, private cloud, or public cloud infrastructure. All user encryption keys are managed by the Keeper SSO Connect service, providing the customer with full control over the keys that are used to encrypt the end-user vaults. This service application can be installed on any Windows or Linux-based server. The primary difference between the cloud and on-prem version of SSO Connect is the way that new devices are approved. In the cloud model, new or unrecognized devices require a transfer of an encryption key through a device approval. The SSO Cloud device approval can be performed by a user on their own devices by clicking on Keeper Push, or admins can approve new devices on the admin console. Keeper also provides automated approval methods using Commander CLI or a hosted cloud Azure function. A detailed step-by-step guide on installing and configuring Keeper SSO Connect is available on our documentation portal, docs.keeper.io. Keeper's Active Directory provisioning method allows you to provision users, roles, teams, and nodes from an on-prem AD environment. Here's an example of that. This node tree is called Engineering and is provisioned through Active Directory. The Keeper Active Directory Bridge software automatically provisions nodes, users, roles, and teams through a service which is installed on any domain-connected server, and it can be customized to sync designated users from AD to the Keeper admin console. Here's my server running my Active Directory environment and the Keeper Bridge software. There are three main tabs here in the Bridge software. On the Connections tab is where you authenticate to AD and to the Keeper Cloud. On the Directory Services tab is where the admin can customize the LDAP queries to filter out only certain nodes, roles, teams, and users. On the Configuration tab, there are several ways to customize the way that the AD Bridge interfaces with Active Directory. Coming back to the admin console, one thing to note is that multiple provisioning methods can be stacked together. For example, you can provision users with Active Directory and then authenticate users with SAML 2.0. Or you can combine SAML 2.0 with SCIM. Having different provisioning methods across different nodes is a powerful capability of the admin console, and it's built to scale for large organizations. Many customers are migrating from on-prem AD to Azure or another cloud SSO provider. Keeper supports this model by allowing admins to configure multiple identity providers and routing users through any IDP. For example, you can configure ADFS with on-prem AD and then migrate to Azure without any disruption in service. In addition to Active Directory and SSO, we also provide SCIM, API provisioning, and email auto-provisioning. SCIM is supported in Microsoft Azure, Okta, JumpCloud, Google, OneLogin, and many other identity systems. It's usually called automated provisioning on the IDP. It takes just a few clicks to configure this option, and Keeper will then receive user, role, and team assignments automatically on the backend. Email auto-provisioning was created for large organizations that simply want users to self-enroll with Keeper. Keeper validates ownership of the domain and only permits authorized users to create their Keeper vaults. When the user creates their vault, they're immediately added to the default role enforcement policy set up for that node. Many universities use this method to roll out Keeper to their entire student population, for example. Last is the Commander SDK provisioning method. Keeper Commander is a public SDK available on GitHub that gives administrators a command line interface or scriptable interface into Keeper. Keeper Commander can automate many different capabilities of the platform, including creation of user vaults, assignment of nodes, roles, and teams, importing and exporting of vault records, vault data management, running reports, rotation of privileged account passwords through our plugins, and replacing hard-coded credentials in DevOps tools. Commander has hundreds of features and capabilities and provides SDKs in many languages including Python, .NET, JavaScript, and more. For more information on Commander, please visit keepersecurity.com/Commander. Next, we'll review roles, teams, and delegated administration. In Keeper's advanced security model, roles and teams serve different purposes. Roles define how users access their vault, what enforcement policies apply to the users, and what features are available within the vault. Teams are used for sharing and can map directly to the provisioning methods of the identity provider. For example, Azure groups can be automatically provisioned into Keeper Teams. Keeper also supports team-to-role mapping. So for example, you can create a team in Azure that's automatically synced to Keeper, and those users are assigned to a designated role policy. Roles are made up of enforcement policies and control how users are able to access the Keeper Vault on their devices. Any number of role policies can be created and then applied to one or more users. Role policies can also be assigned administrative permissions. A role with delegated administration is able to log into the Keeper admin console to manage their designated node. Admin permissions cover the ability to manage the users, roles, teams, run reports, manage the bridge and SSO connection, perform device approvals, and transfer accounts. The enforcement policies of the role is where you can control hundreds of security policies such as password complexity rules, two-factor authentication, platform restrictions, sharing, KeeperFill settings, offline access restrictions, IP allow lists, and many other features. For customers who log into Keeper using a master password, we recommend that customers enforce the use of two-factor authentication. Keeper supports several 2FA methods, including TOTP apps like Google Authenticator and Microsoft Authenticator, Duo Security, RSA Secure ID, and if needed, SMS can be used too. Keeper also supports a smartwatch method called Keeper DNA, which works with Apple Watch and Android Wear devices. Choices of 2FA methods can be limited to users based on the company's preferred methods. For users who authenticate with a SAML 2.0 identity provider, two-factor authentication is typically handled at the IDP level. For example, many customers utilize Microsoft Azure's MFA solution and don't need to force another 2FA method on the Keeper side. Keeper's platform uses device verification methods to ensure that the user is only able to log in and decrypt their vault after a successful authentication from the identity provider. If 2FA is enforced on the Keeper side, the admin can customize exactly how long this device token is valid and therefore how often users will be prompted for a new two-factor code. For example, users on their mobile device could be prompted one time, and users on a web app or desktop app can be prompted every time. All Keeper users are able to activate one or more FIDO-compliant hardware security keys, such as a YubiKey. The platform restriction screen gives admins the ability to lock down this role to access the Keeper Vault only on specific device platforms. The Vault Features screen controls many different user-facing UI and security features on the Vault, such as masking, generated password complexity, reauthentication, and handling of deleted records. The Require Reauthentication policy provides step-up authentication when certain actions are taken in the Vault, such as editing a password. The Purging Deleted Records policy will ensure a certain number of days have passed before a deleted record can be permanently deleted. Deleted items can also be automatically purged after a certain number of days. The Generated Password Complexity policy allows you to specify password complexity for specific website domains. You can also turn on Keeper's Privacy Screen feature at the domain level. Privacy Screen limits the ability for the user to view a password. Additionally, it prevents the user from changing the website URL after the record has been saved. The password generator must be clicked to generate a random high-strength password. On the sharing and uploading screen, admins can control whether or not this role is able to share records. Sharing can be completely restricted, or it can be restricted to certain users. Record sharing with file attachments can be restricted, as well as uploading attachments to records. Exporting of records from the web app or desktop app can also be restricted. On the KeeperFill screen, admins can control the operation and features available on the Keeper browser extension for Chrome, Safari, Firefox, and Edge browsers. The features and options of the browser extension can either be enforced on, off, or not enforced. The Account Settings screen gives admins control over additional security policies related to offline access, email invitations, or our Stay Logged In feature, and also logout timers. The Restrict Offline Access enforcement will prevent users from accessing their vault while offline or in airplane mode. It's important to note that Keeper never stores any clear text or unencrypted data on the user's device. When a user logs into their vault offline, the data is decrypted locally, and they're able to perform limited functionality. The Allow IP list can be used to lock down access to the vault for a particular role, such as an admin role, to a certain set of external WAN IPs or physical locations. For example, admins can require that users with delegated admin access rights are only able to access Keeper from their VPN or home IP. The transfer account permission is a critical role enforcement policy to handle employee termination or offboarding scenarios. Keeper supports the ability for a specific role to transfer a vault from one user to another user. For example, in this case, I want the head of security to have the ability to log into the admin console and perform a vault transfer of any user who is assigned this policy. The account transfer feature is a zero-knowledge operation that allows the Keeper administrator to create a hierarchy of transfer permissions within the system. For example, it can be organized such that the head of security vault can be transferred by the CISO, but the CISO cannot have their vault transferred. When the admin performs a vault transfer, a one-directional encryption operation is performed where the admin is able to decrypt the source vault, re-encrypt the data with the destination user's public key, and then transfer the ownership of the vault records to the destination user. Once a vault transfer has occurred, notifications are sent to the users and the source account is deleted from the system. Keeper Teams allows you to share privileged accounts among user groups. Teams can then be added to shared folders within the vault. Teams can be mapped to roles. If you'd like to automatically assign enforcement policies at the team level instead of assigning users directly to roles. At the team level, you can enforce certain restrictions. Privacy screen can be applied at the team level in addition to the role level described before. You can also disable record edits and disable record reshares. These restrictions will take effect on any shared team folders. Teams can be automatically provisioned from your identity provider using the SCIM protocol. Azure, Okta, JumpCloud, and other identity providers support team provisioning. Teams can also be created through the admin console user interface, provisioned from Active Directory, or programmatically created through the Commander CLI and SDK platform. Here on the Okta portal, for example, you can set up push groups that will automatically create teams on the Keeper side. Teams can be added to shared folders from the vault. Here, I've added a shared folder called Shared IT Records with the QA team and AWS team added. You can add teams and individual users to a shared folder with different permissions. For example, in this folder, the QA team has no user permissions, but the AWS team has full permissions. The records inside a shared folder can be assigned read-only, can edit, and can share permissions for all users in the shared folder. Shared folders have default folder settings that can determine the permissions inherited when new records are added by team members. The security audit section of the console gives admins the ability to monitor the overall password strength and security score of the organization. Summary statistics are gathered by the client devices and encrypted with the public key of the admin so the admin can log into the console, decrypt the reports, and take action to enforce internal policies. BreachWatch, our dark web monitoring solution, is able to detect if a password has been found in a dark web data breach. Users and administrators are notified if any of their passwords in a record have been used in a publicly known breach that could leave your organization vulnerable to a credential stuffing attack or an account takeover. Keeper's Advanced Reporting and Alerts module, called ARAM, is a critical component of the security platform which provides Keeper administrators and compliance teams tools for monitoring overall usage and adherence to policies. The Advanced Reporting and Alerts module tracks over 100 security events and addresses many password-related cybersecurity auditing, alerting, and compliance needs. This module provides insight to assess vulnerabilities related to password reuse, password access from unauthorized users, password stuffing attacks, and insider threats. For example, let's pull up the Admin Policy Change Report. Here we can see any administrative changes in the platform. Clicking on the event shows event details such as the user, device, software version, IP address, and event-specific metadata. Data can also be exported for offline analysis. You can also track the usage of individual records in shared folders by referencing the unique record UID or shared folder UID. For example, I can see in this report any events related to this Amazon AWS root password. Notice that the admin console does not decrypt or expose any secret information. Keeper's reporting engine references the record identifier, which can be retrieved from the Vault interface. To track critical security events, alerts can be created. Admins can create an unlimited number of alerts that can trigger on over 100 different event types and attributes. For example, here's an alert that's triggered upon any policy change event. Alerts can be sent to any number of recipients or endpoints such as email address, SMS, and even Slack or Microsoft Teams through our webhook feature. In this case, I have a Slack webhook set up to receive the alert. It will be displayed in a Slack channel with custom formatting and can even include action buttons that launch the vault. Here's an event sent to my Slack channel when a policy change occurs. We also support Microsoft Teams integration right out of the box. Here's an example of a Teams alert. Event alerts can also be triggered on a particular attribute such as a record UID or shared folder UID. For example, if I want to be alerted anytime a particular password is updated or autofilled on a web form, this can be quickly built. Event data can be streamed into any existing SIEM solution, such as Splunk, Sumo, Azure, Logarithm, or any syslog-compatible destination. Here I have a Splunk connection active. We support both cloud-based and on-prem SIEM solutions. Reports can also be generated automatically on Keeper Commander, our open-source command line and SDK toolkit using the audit-report command. Keeper Commander is our command line CLI, SDK, and secrets management platform for DevOps teams, IT admins, and developers looking to integrate Keeper into their environment. This wraps up our demo of the Keeper Enterprise platform. Please reach out to our sales team to get started. Thank you.